So thank you very much for your patience there. And it's a shame I couldn't be with you today. I've actually been on a cycling trip the last 3 days, and I was just about two hours ago. I was in the middle of a field, lost, and I managed to get to the hotel quickly enough. So it's great to join you virtually. And thank you, Martin and the Highfly team for inviting me along as well. So just to introduce myself, and I'll let Sunny introduce himself properly in his section halfway through. But so I'm Mark. So when Martin said I was one of the senior members of the DBT community, it's probably due to age more than anything else with me. But I've been working with databases now for about 25 years. And so really what interested me about this presentation, and actually the work we've been doing with Highfly around Firebolt, is to try and understand what Firebolt were doing really with databases, and is it possible to combine both scale and low latency queries. That really was the thing that was of interest to us. So in this, so that's me. I'm Mark. I run the company, Rittman Analytics. I'm also very hands-on and do a lot of development work, and also do podcasting and that sort of thing. But it's great to sort of join you here today. And I'll let Sunny introduce himself properly in a moment. Right. Okay. So what I'm going to do is, or the way we'll do this session is about half of it will be just, I suppose, the context really, trying to understand what is this thing called Firebolt, and why should you be interested in it? So why, when there's databases out there such as Snowflake and BigQuery and so on, why should you be interested in this database? And to kind of cut to the interesting bit. It's got some interesting features. It's got some early I suppose you get some early adopter sort of challenges and so on. But actually, it's definitely a very interesting technology and working. And it actually works with DBT as well. So that's obviously the link in what we're doing here. So now, so first of all, what is Firebolt? Okay, so Firebolt is a data warehouse platform that aims to combine both working at scale and but with very, very fast queries. Okay, so typically the trade-off you get is when you scale up a database and you are able to kind of handle huge volumes of data, then I suppose the cost of that is that queries take, I don't know, between sort of 10, 20, 60 seconds to run. So what Firebolt is trying to do is give you the same, I suppose, query latency and response time that you get with maybe even things like in-memory databases and so on, but trying to do that at scale. So it has integration with Looker, with DBT, things like Prefect, Tableau, and so on. And it has a kind of a modern data, I suppose a modern cloud architecture really. So it's available as a service that you consume. It separates out storage and compute. It has things like JDBC drivers, REST APIs, and all those kind of things there. But the context really of this talk is we're going to talk about how Firebolt integrates in particular with DBT and show you it working with Looker as well. Okay. And again, context for this is that so Highfly and ourselves have been working on one particular project, actually doing everything we're talking about today. We're actually doing this in real life now. For confidentiality purposes, we couldn't really talk about the actual project we're working on together. But so the example we give in this presentation is trying to show you some of the capabilities and show you what it can achieve, but with a more kind of like synthetic example, really. But we've been working together with Firebolt and with Highfly on this for about the last 6 months or so now. So I think we know Firebolt fairly well. Okay, so how does Firebolt work? What's the underpinnings in Firebolt that makes it as fast as it's meant to be, really? Okay, so let's kind of go through this. So I suppose the underlying approach that Firebolt take is to try and the way that Firebolt get the database to run fast is by trying to reduce the amount of data that moves around all the time. So if you think about a data warehouse like, say, Snowflake, or even some of the on-premises data warehouses from a while ago, they're predicated on moving around big sort of blocks or partitions of data. Okay, with Firebolt, the idea is to try and make it so that less data can be selected at any one time, which means that more can be put into memory, which means that queries can run faster. Okay, and that's the underlying approach that they've tried to take. Now, the way they do this, I suppose the innovation, the thing that Firebolt brings to it that wasn't there before in other databases is, I suppose one way of thinking about it is think about combining, say, Snowflake with indexes. Okay, So probably most of you are aware of what indexes do on a normal, say, SQL Server type database or an Oracle type database. You know, an index allows you to go and get a particular small subset of rows very quickly. Okay, so what Firebolt have done in effect is combine indexing with column store data warehousing. Okay, so and in particular, there's an index structure called a sparse index, and it's the sparse index and the underlying storage technology that Firebolt use that makes this possible. Okay, so we won't go into too much detail on this now because we've got kind of, you know, because we're not Firebolt engineering, we've only got 20 minutes. But it's if you look at, there's a blog post I've written recently which goes into some of the detail. It's all done through sparse indexing and the column format, the storage format they use to actually store data. And that's called the F3 storage format. So it's their own storage format that has the innovation there, as I said, is the indexing in there, the sparse indexing in there. And you'll see with the example that Sunny goes through after I finish my bit, what the DBT adapter does is it, as well as creating and transforming all the data, it also maintains and defines all the indexes as well. Okay, and that's the kind of the real value in using DBT with this as well. So there's two particular types of index that you get in Firebolt that, you know, we're going to go through more detail in the example. So there's what's called, well, first of all, there's what's called the primary index. So the primary index, let's go back a bit here. So the primary index is a way of organizing the data in the table, physically co-locating and storing the data in a sorted format, in a sorted order. Similar to what you get, say, with column, what's it called? Sorry, called with not what's it called? Excuse me, mine's gone blank. Clustering. Sorry, as soon as you get clustering with BigQuery or clustered indexes with Snowflake, it's a very similar sort of thing. But again, because it's using the F3 storage format and because it's using those sparse indexes, you know, the data is stored in a very efficient manner. It's stored in a sorted order, and that's the kind of first sort of, I suppose, index there. So when you actually come to define your tables in Firebolt, you, as well as putting the kind of create table statement in, you put a clause in there for primary index, okay, and that lists out in the order. I suppose it's the most commonly sort of like filtered on columns. That lists out the actual kind of main columns there in the same way that you do table clustering in, say, sort of like BigQuery. So that's the first type of index. The second type of index is called an aggregating index. Okay, an aggregating index is similar to a materialized view. So think of a materialized view, but stored in a sparse indexing sort of like storage structure. So you, in your aggregating index, you list out the columns by which you group by and the measures you want to be aggregating. Okay, so in a similar way to materialized views with, say, Snowflake or other databases, it will refer to the aggregating index where the query comes through. It's a bit more of a clever sort of like setup. You don't have to have the exact same sort of matching query to match the aggregating index, but this is a form of materialized view, but stored in a very efficient manner. And the last type of index is called a join index, and that's where you go and pre-compute expensive joins between tables, for example, between fact and dimension tables. So to think of it really as, say, think of it like ClickHouse, for example, but with indexes. That's a kind of, I think, a good analogy for how it works. So where DBT comes in here is that the DBT adapter for Firebolt. Okay, so it's worth bearing in mind a few things at start. So first of all, it's kind of it's a kind of beta product at the moment. So there's a few features in there that are sort of not fully mature, but the basic functionality works. So you can use DBT to define your Firebolt tables, to do your indexing and all that kind of work there, and also bring in data from S3 as well. So there's an adapter out there. One limitation at the moment is that it's not supported yet in DBT Cloud. So if you are going to then schedule your work that you're doing with DBT and Firebolt, you need to think about how you're going to do that, whether you're going to do that using something like Prefect or whether you can use your own scheduler. But it's worth looking at now, and we're going to show you how it works in the example we do in a moment. So there's a DBT adapter for Firebolt. And the last thing is Looker. So one of the things that's interesting about Firebolt is that a lot of the people that either founded Firebolt or are running it now are ex-Looker people. Okay, so the general manager is the ex-cart manager for Looker. A lot of people there are from Looker, and so Firebolt works really well with Looker. And we'll show you an example. In the example we show you in a moment, you'll see that kind of in action, really. So just like any other data source, you can bring that into Looker. You can map to it. It's again, it's almost fully supported. Well, it's fully supported, but fully featured. But the benefit of this really is you can start to get dashboards that are sort of split second rather than taking sort of 30 seconds, a minute to run, really. So, okay, what I'm going to do now is I'm going to hand over to Sunny. And so I'll stop sharing now, Sunny. And you can take over and you can talk about actually in practice how it works.
Okay. Thanks, Mark, for a good intro. While we get my slides set up, I think I'm going to introduce myself first. I'm Sunny. I work at Hyper Labs as an analytics engineer. I actually graduated with an economics degree, but I started working in data like 1 year ago. It's been quite a joy to work with Mark the man himself for almost a year now. And I think we can get started with my slides. That's about it. So how does the dbt Firebolt adapter works? So I brought you a scenario here, which is analyzing the Hacker News data. So for those who doesn't know Hacker News founded in 2006 by the startup incubator Y Combinator. And their idea was initially to resurface the old Reddit community. And their data, it's for resurfacing the old Reddit community, so it's very similar to that, except you cannot downvote submissions. And also, Hacker News is very focused on technology, computer science, and entrepreneurship, right? So then this data is publicly available on BigQuery. So you can download that, you can work with that, and that's what we use, right? So again, the data is probably available in Google Cloud Platform. So we somehow stage that to Google Cloud Storage, and then with utility of your choice, you can move it to S3, which then Firebolt leverages S3, dbt external table package. So here you transform the data with dbt. Yeah, right. And then you can build your dashboards instantly with Looker. Then you have your dashboard in let's say in this case, it's sitting on BigQuery, right? So you can actually compare the two dashboards and see what's the difference in terms of performance, right? So again, you extract the data, you stage the S3, you load it, transform it using dbt, and then you build your dashboards in Looker. So how does this work technically? So it's like any other adapter. It's very simple, very straightforward. You pip install dbt-firebolt. You then create a profile for Firebolt, for your Firebolt connection. So you type Firebolt, you separate credentials. Here it's through environment variables because we care about our privacy. And then you specify here, the very specific case for Firebolt, you have to specify an engine name. So in Firebolt, every engine is connected to a database, so it's not a many-to-many connection. And then you have your account name if you have multiple accounts, right? So on the right, what you can see is the subordinate features as of now of the adapter. So here you can see that every materializations except the incremental materialization is supported. Actually, they just 5 days ago, they just released the new version of the adapter, which supports now the append strategy for the incremental materialization. And then you have all the basic features of dbt. You have the primary indexes, which Mark talked about, the aggregate indexes. Join indexes actually are not working as of now. It's the syntax supported, it runs fine, but it's not effective. So like I said, there is not really a concept of database. So every database is connected to an engine. So you can have in Snowflake and multiple databases using the same warehouse. And then you also don't have official concept for schemas. What you can do for schemas, there is kind of way you can create pseudo schemas to just prefix your tables. So for that, there are additional setup recommendations by Firebolt. You can actually add your generate alias name macro, which then basically appends a prefix to your tables based on your schema definition. So here it just appends a WH to every table. Yeah. So our use case is we move somehow our data to S3, right? So then we actually leverage the DBD codegen package. We run it against BigQuery or Snowflake. And then we can generate our sources.yaml file, which is specifically tailored to Firebolt. So for that, we actually had to mock the DBD codegen package to just spit out something which is applicable to Firebolt. And then you have your sources.yaml file. You can actually stage your tables now with the DBD external tables package. And then you do your ER2, right? So then you move on. So the thing you can see below here is, so instead of just recreating the views in Looker, you can actually use the same views in Looker for either DBD or the comparison data warehouse, in this case, BigQuery, right? So you actually include these clauses, which using the Looker's user attribute to switch in between data warehouses. So in this way, you don't need to recreate your views, right? Actually, you sometimes have to recreate views if there's an imbalance between, like, if there is a feature supported in, let's say, Firebolt, but not supported in BigQuery, right? So that I know that, for example, symmetric aggregates in Looker is not supported in Firebolt, but it's supported in Snowflake. Yeah. So how it looks like exactly in practice. So you have your sources.yaml file on the left. So you have your S3 bucket URL here, and then you have your file type, and then you supply your credentials. So here, what's different from, let's say, Snowflake is that you have to actually create a technical user dedicated to Firebolt. You have to give an S3 full access to that role, and then you can list all your columns, right? And on the right, what you can see is that what happens if you use the external table package. So here is just a staging of the table, external table. Yeah. So now we are at the model level of DBD. So here's how you define Firebolt DBD model. So what is really specific is the config block, right? So here you have to specify a table type. You have fact type or dimension type, and then you specify your primary indexes, which is driving the F5 format. So you specify them from low cardinality to high cardinality, like in other cases. And then so basically the F format just orders the data along these dimensions, along these verticals. And then if a new data arrives, it then creates another hash table, which then is going to be merged with the existing like odd table in create time. So they have your indexes. Here it's an aggregated index, you can see. Aggregate index. The key column are the columns which you expect to be in the group calls. So you aggregate by year, by month, by author, or story ID. And then you have your exact like aggregations, right? So then DBD just generates this table as a materialized view. Just on the right, you can see a reminder of what features are currently supported now. So we are not showing join indexes because it's not stable right now. Yeah. So how do these indexes perform in action? So at the top, so these are both like an output or explain query. And then on the top, you can see a query which is running against the table which is not indexed. So here you can see that it actually starts with the comments fact table. That's the base table. And then it runs for 0.67 seconds. And then at the bottom, you can see a table which is indexed. So here, the Firebolt recognizes that there is already a pre-calculated cache table Firebolt, and it actually uses that, and the performance difference is almost like 30 times faster. Right, so why not just create a bunch of indexes, right? So then you can speed up all your queries. So the thing is that it's very costly in storage and also in memory. So actually, when you run these DBD models, it creates all the tables as a create table as select, and then puts the index on top of it and generates it. It's very memory heavy. And also like the best practice is that you define your index, that the index size on your tables should be, and the index size per table size in terms of rows should be like the ratio of 0.5 or less. That's the best practice, I think. Yeah, I think, yeah, that's all from me. Actually, I can pass the microphone back to Mark if you are here. Can you take over?
Yeah, I'm here. Yeah, I'm here.
Mark is going to show you a demo in Looker.
Yeah, and okay, brilliant. So, so I hope this is going to work. It's a YouTube video actually, just showing how the dashboard work. Now, so I'm just going to kick this off now. Now, one thing to bear in mind, okay, so this data set, the Hack and Use data set, although it's kind of big, it's really relatively small compared to the ideal, I suppose, the size of a data set at which Firebolt really kind of starts to make sense. So this is only a relatively small one. It's fast. It runs, you see in a second, it runs about sort of 2 to 3 times faster than it ran in BigQuery, although this is not meant to be a benchmark or any other comparison really with BigQuery. Reason I compared it with BigQuery, and I did the blog posts about this, was you got to at least check to see whether it's actually faster than the thing you bought it from. Really, the size of data set that makes sense really for Firebolt is about, say, 100 gigs or so in size, really. So, once you've got to that sort of level, and certainly the projects that we work on with Firebolt, we're seeing, response times for dashboards going from, say, I don't know, a minute or whatever, down to a few seconds, really. And the way it kind of works, one thing we didn't really talk about in much detail earlier on is you get to select the size of engine that works with Firebolt. So there's concept of engines. And the more, a bit like with Snowflake, the more compute resource you throw at it, the faster it runs, really. So that was an example there of what this demo was like when it ran against the data set from Hack and Use. But certainly the actual response time we see is consistent, really, for actually kind of very large data sets as well, in the 100 gigs or more sort of size. So that was it kind of running again. I'll just show it one more time because I was talking over it as I was doing that here. So you can see there is going to be, certainly our experience is that if you're running, say, Firebolt through Looker, for example, there's going to be an overhead that's added by the Looker kind of query engine, I suppose. So you're never going to get down to it being microseconds really response time, but you'll get a dashboard that is in the kind of the tens of seconds down to 1 or 2 really. And of course, the more elements on a dashboard that are running at the same time, the more things are running concurrently, and obviously so on, really. But you see the response time is pretty good, really, even on this sort of small data set. Okay, so and the last bit really, I'll just show you when this kind of finishes running here, is I'll show you the actual comparison I did at the time to show how fast it was compared to the original kind of, I suppose, running the original data set in BigQuery. So hopefully that will finish in a second. So we're looking right. Okay. So again, don't take this as being a benchmarking. Don't take this as being really rigorously scientifically tested. But running the same, I've got the same dashboard running against the original data set in BigQuery, and the response time was, for Firebolt was I don't know, between 2x and sort of 3x. They're kind of fast really compared to BigQuery. And that's really because of the indexing. It's because of the kind of the optimal storage and so on there, really. And you can see here, then this kind of in the bottom graph there, you can see that the response time of all the Firebolt queries was around, was always consistently sort of like 1 or 2 seconds, whereas the BigQuery ones would spike up to be sort of several seconds and that sort of thing. So it was nice to see. It was nice to see it had an effect on even that smaller data set. But certainly these data sets we've worked on with Highfly have been even bigger, and we've seen much more pronounced difference in speed there as well.